In this technical corner, we're going to be discussing the future of Takumi machine tools, the technological advancements that have been made, and hybrid manufacturing. Takumi is supplied from Leader CNC Technologies in the UK. Paul, what is hybrid manufacturing?
It's a combination of additive and subtractive, and this is a perfect example. The application we're going to see during today's discussion is a really good illustration of the combination.
So, firstly, Paul, tell us the technology behind this.
Okay, so the Takumi machine, it has the ability to print metals, and then of course machine metals in the same way a normal Takumi. In fact, this is built on the H12 Takumi model, which is a dual column, heavy duty machining centre essentially. Now, what they've added to this is the ability to then print on here. So I mean, it's incredible the amount of opportunities that you've got with a machine like this. And you can see here what we do is we build through this application, and by the end of this technical corner we'll talk about how quickly and the differences between doing this in another method would be compared to doing it on here. Just a quick word on Takumi: high precision, high speed. That is what this machine offers in the ultimate in accuracy as well. So for the subtractive element, it's a perfect product, and of course they've added the additive to it too.
So you can find the technical corners on the H series on the MTD CNC platform. Additive manufacturing, hybrid manufacturing, is it the future?
Yeah, and where does it fit? Well, I mean, the key points is you can firstly think about, we see a lot of machines, whether they be mill turn machines, where they're starting to incorporate them into the oil and gas industry, where they're using them for repair work. Here we're using it in a perfect example of basically building a part from scratch, maybe a prototype, and then machining it to the finished part. So it can fit in all kinds of areas. And I mean, the great thing about building a part is that you know the integrity of the part that you're building. So whereas if you started off here with a huge block of material, you don't quite know what's right in the middle of that. You don't know whether it's porous, whether there's a cavity in there. But whereas if you build something up from scratch on a machine like this, you can be pretty much assured that you're printing every area, so you know what the end integrity of the part is.
So what kind of limitations are there in the materials that you can print? Here we're looking at a metal component.
We're told reliably by Takumi here that this head will print mild steels, titaniums, aluminiums. I mean, what an opportunity for companies to really start to try and change the way they think about additive machining. You know, you look at a part like this, for example. I mean, before you would have had to have machined that out of a huge billet, wouldn't you? A huge block. You think of how much that block's going to cost, for one. Secondly, you think of the amount of tooling that you're going to need, the insert wear, and actually machining it down to this finished octopus. And finally, the time that would take. All three of those aspects are, you know, defining factors as to why you might choose to print it and then machine it on a machine like this. Massive
factors. I don't think that we'll ever eliminate CNC removal ever. However, this in addition with that, or with, you know, the hybrid kind of solution is fantastic. What about repair work, Paul?
Yeah, this is an opportunity to do repair work, and also incidents that happen. You machine a part, you make a mistake. Okay, well you can then reprint material and machine it again. You know, when you were in the machine shop, you were forever making mistakes. I mean, think how beneficial this would have been to you. But there is the area, you know, there is the area where you get a part in, it's broken, there's something that, you know, there's something that's not quite right with that component. Now you can repair it, you can remachine it to deliver, instead of having to make a new part.
Absolutely.
Which can happen.
And I mean, this is an example on a 3-axis machine, but I'm assuming that this can be done on 5-axis machines, horizontal machines.
The technology is in the head. The head is then like a tool changer. You know, it's on a BBT back end. It gets exported or transported into the tool carousel. And your finished parts are machined. Now, I wanted to just point out that this particular octopus, they say it was about 3 hours to print. Okay, so 3 hours to do your printing, 4 hours then to machine to the finished part. So total approximately 7 hours. They estimate that if you were to do that out of a block, it would be between 20 and 24 hours to machine. So there is
that's quick.
I'm no mathematician, really, but that's about a third of the time. But it isn't just that, is it? It's what we were saying earlier. It's about the tool wear, less cost in material, because you are only using material that you need as opposed to machining material that you don't.
Absolutely, Paul. What are the barriers to entry?
The barriers to entry in this one would be cost, because it's not, it's not going to be as cheap as buying a normal machining centre. But I think it's just apprehension. I think the barriers to entry are apprehension. People thinking, really, where am I going to fit? How am I going to use this? Engineers are great at making and developing strategies, and that is where this machine needs to be encountered into their production processes. There are two things that change the landscape of engineering, and it's automation is one, but processes is the other. And this process now has the ability to change the way people think and to change their production processes.
So in your opinion, Paul, would you say that hybrid combined with automation, combined with inspection on the same platform is the future?
This is like a massive mill turn machine, right? You can go and buy a mill turn machine because you want to mill and you want to turn, or you want to turn and you want to mill. You could buy two machines here. You could go buy a printer and you could print this part, and then you could put it onto this machine and you could machine it. But the same disadvantages apply to this as they do to that. The fact that you're not doing everything on the one machine, you're having to move the logistics and all of the rest of it, whereas this is all done in one. This is never going to replace CNC machining, because this machine will machine to microns. You cannot print this material to microns, as far as I know, unless someone wants to tell me any different. But what you can do is the combination is you can achieve both results.
Paul, it's been an absolute pleasure. This is the future from Takumi. I believe that this technology is already available, so contact Leader CNC Technologies to find out more. Thanks, Paul.
Thank you.